Hi, good morning, dear students. Welcome to statistics class. Our topic for today is about completely randomized design. Before we go on, let's discuss or define some terms. Experimental layout refers to how treatments are allocated to the different groups of sampling unit or experimental unit in an experiment based on experimental design. And then we have this design structure. It refers to grouping of the experimental units into homogeneous groups or blocks. And sometimes when you are asked what is your design structure and experimental layout, these two terms are used interchangeably. So it's about the arrangement of treatments to your experimental units. And then another term is a single factor experiments. So experiments in which only one or only a single factor varies while all others are kept constants are called single factor experiments. So in such experiments, the treatments consist solely of the different levels of single factor or single variable factor. So in other words, all other factors are applied uniformly to all plots at a single prescribed level. So you can call that as a single factor experiments. So let's have an example. Most crop variety trials are single-factor experiment in which the single variable factor is variety, okay? So a single variable factor is variety. And then the factor levels such as the different variety or the treatment levels. So that is the factor levels are the different varieties. So in other words, only the variety planted differs from one experiment plot to another, and all management factors such as fertilizer, insect control, and water management are applied uniformly to all plots. So the only thing or the factor that differs only is the variety. All other factors are held constant or uniform to every experimental unit. So that is the single factor experiments where only one factor differs. And then we have this another examples for you to better understand. For example, fertilizer trials where several rates of a single fertilizer element are tested. And then insecticide trials where several insecticides are tested. So the only factor that varies is the insecticides or insecticide levels or different brand of insecticides. And then another example is plant population trials where several plant densities are tested. So those are other examples of a single factor experiment in which only one factor varies. So let's go on with our topic, the completely randomized design. Some say it is the simplest experimental design, or the most basic experimental design. And the allocation of the treatments is done by randomizing the treatments completely over the entire set of experimental units without any restriction imposed on the unit. So in other words, treatments are allocated to experimental units completely at random, and the factor under test is the only criteria for data classification, or the treatment level is the only criteria for data classification. So in other words, this factor, one factor, is the only thing or factor that differs among your experimental units, while other factors are held constant. So we will use completely randomized design when, number one, your experimental units are homogeneous. So for the CRD, any difference among experimental units receiving the same treatment is considered as experimental error. So hence, the CRD is only appropriate for experiments with homogeneous experimental units such as laboratory experiments where, in this laboratory experiments, where environmental effects are relatively easy to control. So the environmental factor does not vary. So because it's a controlled experiment. So for field experiment where there is generally large variation among experimental plots, in such environmental factors as soil, the CRD is rarely used because sometimes the fertility level varies. So sometimes CRD is not appropriate in this case. So we will use another experimental design or design structure, which we will discuss in another topic. But for now, we will use only CRD if your experimental units are homogeneous and there is an effective local control. In other words, you can control or other factors are held constant. And so what are the requirements? So N is your population size. So N must be greater than your treatment. So in other words, your sample size must be more than your treatments because we have to account for the replication. So and homogeneous experimental units and the treatments to compare. So if you have a balanced design, your sample size must be replication times your treatment. So for a balanced design, N is equal to R times T, where R is the number of replications per treatment. And so for the unbalanced design, because there are treatments that are replicated not uniformly. So for example, your treatment 1 has replicated 2 times and then your treatment 2 is replicated 4 times. So you can call that as an unbalanced design. So for samples, you have N is equal to replication 1 plus replication 2 plus ellipse and then replication until how many treatments do you have. So where Ri is the number of replicates or replications per treatment or number of replicates of the ith treatment. So we have this randomization procedure. Number 1, determine the number of replications per treatment. So how many replications per treatment do you have? So for example, for a variety, I would replicate it 3 times. Okay, so first you have to determine the number of replications per treatment and then label the experimental units from 1 to n. So you see, for example, in a field experiment, or you have the plots, okay? So label that from 1 to n. And then generate n random numbers. How do you generate random numbers? If you have your scientific calculator, then you could use or generate random numbers. Or you could use the random numbers tables. And then rank these random numbers, and then the first ranks correspond to the experimental units which will be assigned the first level of the treatment. And then the next replications or ranks correspond to the experimental units which will be assigned the second level of the treatment. And then the next RI ranks correspond to the experimental units which will be assigned the ith level of the treatment. So let's have some example for you to understand it better. So an experiment was conducted to determine the effect of the levels 30, 60, and 90 kilogram per hectare of nitrogen on the yield of the variety of corn. So we have these treatment levels, the 3 treatment levels. We have this 30, 60, and 90. So these are the treatment or the factor levels or the treatment levels. And then 12 homogeneous plots of 5 by 30 square meter were prepared. And then we have these 4 plots were randomly assigned to receive a level of nitrogen. So our treatment, of course, based on the example, is the amount of nitrogen. And then the treatment levels, we have this 30, 60, and 90 kilogram per hectare. So you have to differentiate what is the treatment and then the treatment levels. So when you say treatment levels, some are this category, some for example, and other things are varieties. So these are the treatment levels or the factor levels. And then we have this experimental unit. So this is the plots. When you say experimental units, this is the units that will receive your treatment. And then we have this response variable, and that is our yield or our dependent variable. This is the yield. The one that we will be measuring is the yield, and see if there's really a variation or if there's really a difference in our yield given that they have this or given they're applied with different levels of nitrogen. So randomization procedure number one, again, number the plots from 1 to 12 because based on the problems, we have three, three factor levels and they are replicated 4 times. So 3 times 4 is equal to 12. So that is your number of plots. So first step is you have to number the plots from 1 to 12. And then generate 12 random numbers. For example, in your number one plot, then you have generated a random numbers on your calculator or on your random numbers table. So for example, in our case, I've used the calculator. I have generated these 12 random numbers. And then on the first random numbers, I have this 0.867. And then the number 2, on the second plot, I have the 0.711. And then in the third plot, I have the 0.903. And for the fourth plot, I have 0.208. And then for fifth plot is 0.997. So on until 12. In the 12th plot, I have generated the random numbers of 0.526. So the next step is to rank these numbers. So I have here the first one is this the last number or the last number on the first column. So that would be our so at this case, so this one is our rank number 1, 0.146, and then the rank number 2 is this 0.161. So you have to rank every random numbers you have generated in your calculator. And then the next step is to the first 4 ranks will correspond to the plots which will receive 30 kilograms per hectare of nitrogen. So that would be our treatment 1. Okay, and then the next 4 ranks to receive 60 kilogram per hectare, and that would be our treatment 2. And the last 4 ranks to receive 90 kilogram per hectare of nitrogen. So that would be our treatment 3. So you have already generated the random numbers and then you have ranked those random numbers. And then the first column, that would be for the treatment 1. That this would be the experimental units or the plots that would receive the treatment 1. And so we will have this final layout. So again, the first plot, so if you can see here, the rank number 1, here, the lower part, this is treatment 3. So this plot will receive the treatment 3, and then, and the 2, and then this one, rank number 2, so here, they would receive the treatment 2. And then, for this sequence here, the third plot, so we will find the third rank random number. So this area is, they will receive the treatment 2. So that's why this is the treatment 2. So this plot, where this experimental unit will receive the treatment 2. And then for the fourth rank, where's the fourth rank? So this is the fourth. So it will receive the treatment 1. And then for the fifth, we'll find the fifth rank. So this will receive the treatment 3. And then for this sixth rank, so this will also receive the treatment 3. So that's how you will present your final layout or your experimental layout in CRD or in completely randomized design. So there are also some processes in presenting your experimental layout, you can refer to our textbook or into this example. So that is the procedure or the randomization procedure for the completely randomized design. So before we end, let's have some reflection. And James 4:17 it says, "Therefore, to one who knows the right thing to do and does not do it, to him it is a sin." So in all things in life, there's the right thing to do it. So in even experimental researchers, there are appropriate experimental layout. And if you do not follow the appropriate experimental layout, then it will be accounted to experimental error. So see you in our next topic. We'll be tackling about the randomized complete block design. God bless you.